I'm really, really happy and proud to introduce our speaker for today's colloquium, Amy Ko. Amy is, and I'll read the bio here, just a piece of it, professor at the University of Washington Information School, the Paul Allen School of Computer Science and Engineering. She co-directs the UW Center for Learning, Computing, and Imagination, where she studies computer education, yay, HCI, humanity's individual and collective struggle to understand computing and harness it for creativity, equity, and justice. With her collaborators, she's invented many programming languages and tools to support debugging, program understanding, reuse, and learning. Founded and sold a venture-backed startup, congratulations on that, focused on software troubleshooting, developed numerous ways to weave equity and justice into computing education pedagogy, culture, and technology, and impacted local, state, and federal K-12 education policy through community organizing and advocacy. So we are just delighted at ECS at UC Berkeley to welcome our wonderful speaker, Amy Ko. Let's give our speaker a hand. Woo!
All right, thanks a lot, Dan. It's so weird sometimes to hear introductions like that too, because I'm like, wait, did I do all of that? I don't remember. It just adds up somehow over time. Thank you for being here and for making the space for this conversation. I think I want to start by naming the elephant in the room that probably is on most of our minds, and that is that this institution, my institution, all of academia, are under attack right now. Our federal government is doing everything it can to make sure that talks in general and talks like this don't happen. And I think that when we don't speak openly about the truth, and let alone engage in free inquiry about the truth, right, we're not doing our jobs. And so all of you being here is a kind of resistance, right? We're having the conversations that our current government doesn't want us to have. So thank you for being here. Thank you for being part of that. If we leave this talk today with some ideas about how to move forward together, we'll hopefully start building the worlds that we need and not the worlds that the federal government wants us to have. So on that somber note, let's just jump back to a simpler time. 1997, this was my junior year of high school. Here is me at a computer at 15, a closeted trans girl hiding from myself in digital worlds. Despite growing up in a really wealthy suburb of Portland, I was poor. My parents knew little about computer science or academia. All I knew is that I couldn't afford private universities or out-of-state schools, so my best option was to go to Oregon State University, where my tuition was mostly free. And I wanted to study CS to get out of poverty. That was my goal. I didn't really care about it for what it was. And at the time, CS was something very, very different to me. I'd spent my middle and high school days learning in solitude with no peers, no teachers, just me and my TI-82 graphing calculator, Turbo Pascal, some old defunct 286 PCs in my abandoned high school computer lab. And really a lot of books. They were my teachers. A bunch of technical books from Powell's Technical Bookstore in Portland. That was my whole world of computer science. And it was making weird graphics and weird games and weird animations and working on them with my friends. And of course, then I got to college and it was something very, very different from that too. And so CS to me was something very personal, and it became something that was much more about somebody else's ideas about it. At the same time, I had these amazing teachers. I had a physics teacher who wanted me to teach him how to make simulations. He said he'd tutor me physics if I tutored him programming. I had a math teacher, and I wanted to make these virtual worlds built out of ellipses, and I couldn't figure out how to make these old computers do roots fast enough. And so she found this MIT professor that her Ph.D. advisor knew, who knew a lot about doing faster computation on roots, and I got to connect with them. So I had this amazing public education system that transformed my ability to learn and my sense of what was possible to learn too. And so you contrast that with now, right? All of that isolation with those really powerful teachers to 16, 17 years ago. This was at the end of the Obama White House administration. It fueled this movement, CS for All, and really transformed through federal funding the idea that some of these kinds of learning experiences are something that everybody should have in the United States and probably even the world. That was the general idea. And now there are millions of students who are trying to do this learning, desperate to join computer science departments like this one, to seek some of that economic opportunity that I was trying to seek, but also things like prestige and power and wealth and other things, whatever their motivations are. Some students have teachers, they have tutors, they have classrooms, devices, curricula, role models, peers, all of these things that I didn't have, and I think that is a great success. But that is not most places. In most schools in this country, there are still no CS classes, there are no teachers, there's no community, there's no pathways, there's not even awareness of what computer science is or how it's changing our world. It is completely absent from those youth lives. And partly that's school funding, right? Our nation's buildings are crumbling. Conservative politicians are trying to move funding away from public schools to private ones and create more situations like this, where schools don't even exist anymore, students don't even have opportunities to learn. And so there's a lot of things that if we want CS to be happening everywhere that we need. We need teachers, culturally responsive curricula, professional communities for teachers, we need policy changes, we need functioning buildings for our public education system. This is the US. Yeah, this is an abandoned school, and there are many of those. A lot of stuff that we don't have to make all of that work. But there is one other really important thing in computer science teaching that we don't have that I want to talk about today, and that is programming languages, which I'll just shorthand as PL for those who don't know the academic lingo. We have programming languages, but we don't have programming languages that work for everyone. They are built by and for the few, right? The small, kind of elite sometimes groups of people who know how to build and design programming languages, and are often designing them for things that are not for learning, and certainly not for all of the people in the world in all of our beautiful diversity. And this includes Java and Python and JavaScript and C#. Yes, all of those professional languages don't work for a lot of people, but it's also the educational ones that don't work for people. Things like Scratch and Snap and Pirate, they're designed to support learning in some ways, but they still have baked into them learning that works for dominant groups that we tend to see in our classrooms. And let's just lay this out a little bit. Students with disabilities, they can't read or write code, access content because we build programming language tools that require pointing, sight, other kinds of abilities, and we bake in the idea that if you don't have those things, you don't get to participate. English language learners, multilingual learners, they can't learn because they're forced to learn English before or during their computer science learning. Some of you in the room probably had to do that. Was it easy? Not really, right? It's a lot harder than doing it in your fluent languages. Students without devices or without the internet, they can't enroll in CS classes that use programming languages that require these things to practice at home. Those are basic digital divide gaps, and we bake in the assumption in a lot of our programming languages and tools that they do have those things. Everyone but white boys in Western civilization have to leave their identities behind, trading them for the capitalist ideals of efficiency and domination and extraction, all of which are baked in to the ways that our programming languages work and how they're used. And neurodivergent students have to wrangle PL and tools and documentation that demand particular kinds of communication and particular kinds of attention, and if they don't, they will not thrive. And so that leaves us with this question. What would it mean to design educational programming languages that really actually do work for the full diversity of humanity and not just for the groups that they've been designed for historically? So what we're going to talk about here is a little bit about my background, just a slide on that. We'll do a really brief overview of some conceptions of justice. And I want to start there because this is building upon a lot of other people's ideas. And then I'll focus mostly on 7 justice-centered requirements for educational programming languages. I'll show some examples of bad systems, good systems, some aspirational examples from my own lab's work on a language we're calling wordplay. And I'm hoping that you'll leave with a couple of things. One is an argument that I'm giving you for you to mull over and debate and discuss whether or not it's actually sound. And second, questions and maybe some possible answers about how to advance justice in programming language design, and for education in particular, but maybe more broadly too. So why am I talking about this? Why do I use the word justice? I've got this mixed background in computer science and psychology and design, and lately over the past 10 years I've been doing a lot of learning about learning sciences and education. I am privileged in many ways, right? As a full professor, security of employment, I can do a lot of things that most other people can't do. But I'm also marginalized in lots of ways. By my race, by my gender identity, by my politics, and by my ideas, particularly in computer science, the ways that I think about CS are pretty much on the margins. Most people in CS don't think about it this way. But I also do things like I design and build programming languages. I study learning about computing. I work with teachers, schools, community groups, and all kinds of marginalized communities, particularly trans youth these days. And so I have a sense of the needs that they share with me. And so I'm here to sort of reflect those back to you in an intellectualized form. So what does better mean, and what does everyone mean? I want to start with that as a foundation, and then we'll jump to some of those requirements. So first, raise your hand if you know who John Rawls is. Some of you have read Rawls. Good. For those who haven't, one of the seminal works he wrote was A Theory of Justice, which really defines justice around two really simple ideas. One is that every person deserves a claim to the same equal rights and basic liberties. There shouldn't be any sort of birthright to greater freedom than other people have. So that's one basic idea. And the other is that social inequalities have to satisfy two conditions, that they must stem solely from equality of opportunity, not birthright, and that they must be to the greatest benefit of the least advantage. So if there is some inequality, it should really be centered where the needs are. And that's a basic definition of equity. This is an idea, of course, that's been quote unquote banned by the executive branch of our government, but it is still just a fact that people have different needs, and if you put resources where those needs are, good things happen. So that's Rawlsian justice, but we're going to grapple with a few others too. One is educational justice, and some of the seminal works here are things like Paulo Freire's Pedagogy of the Oppressed. And his idea was he rejected school as a context for depositing knowledge into people's minds. This setting, where you listen and I deposit into your mind, he said, no, that's not how learning works. And he's right, this is not the most effective way that we could be having this conversation. His idea was that liberatory learning is really discursive. It's about dialogue and community organizing and community building, and that collective critical consciousness about people's understanding of the world and their limiting situations in the world, that's the source of real learning, transformation, and liberation, not skills and knowledge deposited into brains. Bell Hooks, some of you have probably heard of her. She built upon some of Freire's ideas in Teaching to Transgress and really talked about Freire's ideas is fundamentally right with a couple of exceptions. One is that he forgot about racial and patriarchal capitalism as an organizing structure for all of the kinds of things that happen in society, including education. And so she tried to bring those into his ideas and manifest what they might look like. And so she really advocated for school to be a place where these forces are seen by students, where we talk about them, and where we connect them with students' lived experiences and identities and desires for change in the world. And then we get to things like design justice. This is the last one. I promise we'll be done with philosophy after this. Sasha Costanza-Chock wrote Design Justice recently, just a few years ago, and really applied a lot of these notions of justice to design, where design is deciding what the future might be, imagining the futures that we want. What are those desirable futures that we're trying to create? And Sasha talked about design justice as centering many different things, healing and empowering communities, centering direct stakeholder voices, prioritizing community impact over design intent. The rest of this bulleted list of things really are things that she sort of derived from engagement with community-based design work. These are the kinds of things that communities say they need design to be. And so that's another place that we're drawing upon from here, is saying this is how we should go about deciding what should be, and this also applies to programming languages. So what does any of this have to do, or what does it mean for educational PL? Well, I worked with my colleague Ben Shapiro, and not that one. I have to say that, this is what he says, so he puts that R in front of it. But yeah, this is like the good, nice, kind Ben Shapiro who believes in equity and justice. My doctoral students as well, Jane Everson and Megumi Kivuva, what we did is took all of those theories of justice and took all of the challenges and problems of educational programming language design and tried to understand what would have to be true about educational programming languages to satisfy the conditions of those conceptions of justice. And so in some ways, this is sort of like a classical software engineering requirements analysis. What has to be true about these things to meet these needs that we have? So it's pretty straightforward in that way. But in other ways, of course, it's really complicated because justice isn't simple. So we'll talk about some caveats in a bit. So what we ended up with is 7 requirements for educational programming languages. And I want to talk to you about those 7, just work through what they might mean for design, and then we'll talk about next steps for them. So we started with Sasha's design principles, community design principles, as our foundation. And from there, we looked at intersections between those principles and the spectrum of marginalization in education that educational justice theories have really looked at, and found these 7 design requirements where we think that if you were to meet any one of them, you'd make some progress. If you were to meet all of them, it's not that the world would be perfect and everything would work well, but that would be more progress than one of them. And so these are the 7 that we're going to go through. And there is an acronym if you want it, which is Altcode. That just felt cute. But their accessibility, educational programming languages should be accessible, liberatory, transparent, cultural, obtainable, democratic, and enduring. These are these 7 human values that we landed on. So a few caveats before we jump into these. There are 7. It's not a magic number. There could be 14, whatever. So this work isn't done. It's just an offering to start the conversation. 2, we don't claim that this is the right notion of justice. There are many other theories of justice. Justice is also something that is always evolving too, as new voices get brought into conversations. And so this should be something that we abandon. Right? This is a place we start the conversation, and as more people are brought in to a coalition and working towards these goals, we'll probably change these and discard them and come up with new ones. And that is a normal process of scholarship. And then third, we do claim that if they were met, there would be a lot more people globally who would be able to learn what programming languages are and how to use them, and probably use them for solving problems in their communities in ways they can't do now. And so that's a material consequence, we think, if we focused our attention on some of these. Last caveat before we jump in, I'm going to give some examples of systems that are doing this well, or weird experiments we're trying in our lab. And I'm going to label some of these things good and bad. That doesn't mean that all of these are wrong or inherently bad. It just means that they're not meeting some of those requirements. And that's okay. We can be self-critical about the things we've created and try to make better things. And so this is really an exercise of professional critique, not of criticism of the makers of these things. And so you'll see me talk about a lot of caveats to all of them. The examples I'll give from our lab are from a system called Wordplay that we've been working on. It's an educational programming language and platform. It's not because Wordplay is perfect or the best or what everybody should be using, but just because it's doing something different than what other platforms have been. So think of it as another point in a design space that helps us think about what else the world could be beyond what we have now. With all of that set up, let's talk about the first one, and that's accessibility. So what is the requirement? Learners and teachers should be able to use the full functionality of an educational programming language with whatever input they can provide and whatever output they can perceive and comprehend and use. And so in practice, this means not just mice and keyboards, but speech and braille keyboards and braille displays and switches and gaze, anything that they might need to use to interact with and produce code and understand it and reason about it and navigate it. This should be table stakes. It should all be included. And if you think about some of the systems you use now, I think you can probably guess that most of them are not supported. And it's not just perceptual and motor physical, but also diversity in things like reading abilities, learning, attention, sensory processing, all of that diversity of the way that our minds work and the way that we can use our bodies and the way that we can use our senses should be included in the design of languages. This is fundamentally a disability justice action. Everybody deserves the right to participate in our computational worlds, and that includes in making them, independent of what abilities they were born with, or they lost, or they gained over their lives. The world we have right now is designed for mostly sighted, hearing, healthy people. The world should be designed in a way that eliminates that assumption and just makes it work for whatever our abilities are now and whatever they might be in the future. Scratch is a little broken in this regard. If you haven't heard of Scratch, this is just a block-based editor environment where you can make simple animations, but it mostly requires the use of a pointer. You have to have a mouse or use a touchscreen, and if you can't use a pointer because you're blind or because you have motor tremors or any other reason that might be, you can't use Scratch. And yet it is ubiquitous in K-12 computing education right now. Most people are choosing that, which means in every single classroom where they do, the kid that can't do these things is just categorically excluded. Or if a teacher doesn't want to exclude them, they just don't teach computer science, or they try to choose something else. And so that's a big problem. And the issue here, of course, is that even though these have been really transformative in lowering barriers to learning about programming languages, all of the advocacy to try to get the Scratch team to make this accessible, even just basically screen readable, hasn't worked despite multiple rewrites of Scratch. The team has not centered this requirement. It has neglected it and said that it's not a high priority for the team. And the consequences are material. Better, Quorum. This is Andy Stefik down at UNLV. This is designed to be highly screen readable for learners who are blind or dyslexic or rely on screen readers for other reasons. It also offers a lot of screen readable output like 2D and 3D graphics. And it's been widely adopted in schools for the blind as it's really the only screen readable language and IDE and platform that works really well in that way. It has its own quirks and flaws and other things, as all PL do, but it does better on this dimension. For wordplay, we're trying to do similar things. You can see here, they're just navigating a program and the screen reader's reading all parts of the program.
Evaluate, cross-eyed grinning face with stuck-out tongue. Find,
including the emojis.
Evaluate, speech bubble. Function. Evaluate, translate.
Oops. And so what we're trying to do here is not only achieve the baseline web content accessibility guidelines level of compliance for screen readability, but also start thinking about things like what are the basic infrastructures that we need to make things like speech input and to work for code editors? What are the kinds of new interaction techniques do we need to make really rich, high quality experiences for Braille keyboards, for example? So there's a lot of things here where there's a whole open space of possibilities. And that gets us to some of the questions that we might ask about accessibility. Few PL are designed with learners with disabilities around the things they might want to make. So what are the kinds of media that if your primary sensory experience might be gaze or sound or movement, what are the kinds of media might we make possible to create through that medium? What does program output look like? And then what are all of the tools that we'd have to build to make it possible to make those things with those input and output media? So that's one big question. How can code editors seamlessly integrate speech and audio feedback? How can program output of all kinds be made accessible? We've done some progress on things like data visualization, and Stefik has made some progress on 3D graphics. There's a lot of other kinds of program output that we create. What does it mean for all of it to be multimodal, even though it's designed for one mode? And then how do we make PL easier to make itself more accessible? How do we help people learn how to build their own programming languages at the same time when they have to use all of these inaccessible tools to do it? So that was accessibility. I'm going to build on that and talk about this liberatory requirement. What does it mean to foster critical consciousness about computing in the design of PL? So this claims that educational PL must empower learners with new conceptions of the natural, social, and artificial worlds, enabling them to imagine futures of computing that dismantle racial, patriarchal capitalism, and colonialism. There are some reasons why we choose those words, but in practice what this means is centering the reality that computing is simultaneously amazing and powerful and beautiful, and also kills people, harms people, marginalizes people, disempowers people. Both of those social processes are happening at the same time. And knowledge that that occurs and how it occurs and what role computation and programming languages play in it is an important thing that programming languages should make transparent to learners. And so making space in PL design and tools and tutorials and communities for the political nature of computing, that's a really key part of this requirement. So why? Well, Free already talked about critical consciousness. That's really what we're building upon here. And the idea is that to have a just world, everyone must understand how and why it is unjust in relation to their lived experiences, so we can come together to fix it. And that is the path to justice that he talked about. And that includes the computational world, and programming languages are really key media that shape our computational worlds. And so if you think about that as a centerpiece of where our worlds, our computational worlds come from, if we don't reckon with all of those aspects of PL that produce those worlds, we will never change that world. So here's an example of not reckoning. This is a programming environment and language called Code Combat. It's a for-profit platform that centers war and violence and, quote unquote, the feeling of wizardly power at your fingertips by using typed code, and learners as a factory worker producing more than 1 billion lines of code through all of their playing. This is an example of erasing the reality that code is literally a tool of war. That's where it came from. That it's used to more efficiently kill people at scale, to silence resistance to dictators. All of these things at play get covered up, papered over by this narrative in this particular environment. Well, what would it look like to not do that? We only have gestures in this direction. I'd say this is the least explored. One was a system that we had a while ago called Gidget. This was a debugging game where people would fix little problems that a little robot was struggling to fix itself. And so we framed compilers and programming languages as fallible, ignorant, but reliable tools. So rather than framing it in authoritative terms, we had this robot really say, I don't know what's going on. I don't understand your message. I wish I could understand better, but I have limitations. And so that was a really basic idea of trying to position compilers, essentially, as kind of powerful but really narrow things that don't have any inherent intelligence to them. They only have the intelligence that they're given. In wordplay, we're trying to do something a little bit more, which is thinking about language constructs in the language as anthropomorphized with personalities and relationships with each other that really center the limited and narrow views with which they conceive the world. As an example, here is some documentation about the conditional statement in wordplay. It's just represented by the question mark. It says, I think I'm supposed to make decisions like this, but have you ever thought about how we decide? Doesn't it seem like decisions should be more nuanced than just yes or no? Deciding between true and false, all there is. Aren't you worried that if these are the only kinds of decisions we can make, we'll be missing some important context about the world? You might have noticed that conditional only knows how to ask questions. It doesn't know how to really answer them too. And so we try to build into all of these different personalities this inherent implicit skepticism about the capability of any part of the language expressing all possible things or being all possible things in a computational sense. And so we see seventh graders that see this kind of starting with a place of skepticism around like, oh, this is interesting, but it couldn't possibly do everything. So what can it do? And what can't it do? They start their conception building around it from that perspective, rather than computers are all powerful and I just have to master them so that I can dominate everyone else in the world too. So we have some questions to answer. Can programming language syntax and semantics be socio-political? What would it look like for that to be true? What are the opportunities and limits of programming languages themselves in promoting learners' critical consciousness about the good and the bad of computing in society? And how might liberatory PL be resisted by schools? Like, are there schools that will not want wordplay in their school because it has all of these ideas in it? Those are really important things for us to ponder. Next up, we have transparent. This is all about making code comprehensible. And so the requirement here is to foster youth agency via program comprehension. Program execution must be navigable in both directions and at multiple levels of granularity. It must be possible to know what the machine is doing. This is really about agency. Learners should feel like they understand and have control over program behavior rather than it controlling them. In practice, this might mean flexible, accessible control over the speed and direction of a program's execution. It may be offering explanations of program execution that enable youth to understand what programs are doing and how they do them. And this really stems from the idea that one cannot critique or control or reimagine something like computation if you don't know what it is or how it works. Bourdieu described this understanding of our institutions and our social worlds as really central to liberation from our symbolic domination. And in some ways, that's what programming languages are. They're a form of symbolic domination. And so the incomprehensibility of how programs work and how they execute to most youth who are trying to learn them, that has really enriched and empowered a really small elite group of people, us, to control the world and define the terms of that domination. And so really centering comprehensibility and transparency, that's central to agency. So most things are terrible about this. I think we all know that debugging is hard, program comprehension is hard. Here's a Stack Overflow post of, I've installed a Java extension pack and it includes the debugger, but when I try to run my Java code, all I get is this text and nothing in the output section. They can't even use the debugger or get it started, let alone use it productively to answer their questions. Like, this is the experience of most people around trying to wrestle with how programs are executing. We have lots of examples of something that's slightly better. I kind of like how Racket and Dr. Racket do really simple things around reversible steppers that let learners go forward and backward and not feel like they're stuck only marching forward in time, but just getting to have control over understanding step by step what's occurring. We do something that's a little more ambitious in wordplay, which is just arbitrary movement through time. And so here's a little wordplay program where there's a cat playing with the letter O. And at some point, let's say we just want to pause and drag arbitrarily into the history of the program and just see what's going on. We can do that on this time slider. We can step back, forward, and backwards. And we can even choose lines of code and jump directly to where they last executed as well. So any kind of reasoning that somebody wants to do in any direction about what was happening, that is possible here for free with almost no overhead. If you want to know how, I can talk about that later. How do we make all educational programming languages support that kind of reversible, granular inspectability to foster that agency? And maybe there's ways of us using LLMs to explain program execution for different literacy levels. Maybe we can have transparency in ways that actually supports liberation too, and critical learning about what programs are doing and why. We haven't explored most of these things, right? We're really just at the level of trying to make things comprehensible. Oops. Okay, 3 more to go, and then we'll wrap. Cultural. This is about embracing all languages, cultures, and values. Educational programming languages must be culturally responsive and sustaining in how they are designed, explained, and framed, enabling identity-inclusive pedagogy. This means supporting multilingual learners, drawing upon many cultures to describe and explain concepts in a language, not just Western white settler cultures, questioning the Western cultural ideas that are embedded in computer science itself, including things like binary truth values, discrete math, rigid categories. This is all about, in some sense, decolonization. Our social worlds are shaped by a history that has centered the culture and language of colonizers and steadily erased all other cultures. That continues today. And humanity deserves to shape the cultural worlds that we live in, including restoring those from the past and creating new ones. And that is not the world we're currently building in computer science. In fact, computer science has not only not resisted colonization, in many ways it's embraced it and amplified it, and it's even itself become a discipline that itself colonizes, redefining and displacing the ideas of other disciplines with its own at the expense of nuance. As an example, when I showed up as a computer scientist to my information school, most of my information science colleagues were deeply skeptical about my presence. They thought that I would come and erase their ideas because that's exactly what happened with Google. It's exactly what happened with all of the other ideas of information science, is they were taken over and replaced by computer science. And that's happened in discipline after discipline. So what does it mean to do that? Well, here's some examples of doing it poorly. Python, syntax is English only. There's no translations. There's only a few non-English locales of documentation. Python 2 didn't even support Unicode, which meant you had to only use Latin characters. Libraries are full of English metaphors like pickle and nanny and ABC. Even the Zen of Python, right, the core principles of the philosophy for the design of the language, they're in tension with diversity. There should only be one and preferably only one obvious way to do it. Well, obvious to who? Like, what do they need to know for that to be obvious? All of these things are made up anyway, so what would be obvious? Special cases aren't special enough to break the rules. That sounds a little bit like if you don't see things the same way everybody else does, you don't belong here. This language isn't for you, or right? So there's weird ideas there that kind of get flowed into the choices that Python makes. You can see that debate playing out here with a person wanting to do Python in Spanish syntax. Here's this project I'm working on. It's all about translating Python into Spanish. And then somebody replies, as a native Spanish speaker, this is cool. Trying to help students who still can't understand English is a great and noble goal. But I must say that learning programming like this might be counterproductive for students. I don't want to discourage you. Just let me say that if students want to learn English keywords, that's the way they have to survive in the world. That's the gist of this. Accept the colonizers, forget your culture, move on. Hedy, my colleague in the Netherlands, Felina Hermans, did a really interesting project where there's 47 different grammars for the same language in 47 different languages. Same platform, same content, but different languages. It's really a powerful expression of what it might be like to do this radically with some caveats. Caveats like you can't mix languages together, which is kind of ironic because most Europeans are multilingual, right? They speak their language and bordering countries' languages, but it's very segregated here. You have to do it all in isolation. In wordplay, we try to mix them all together in a very like melting pot American kind of way. So all names and documentation can have any number of language tagged aliases, and that lets us skin programs as English or Spanish or Arabic, and that immediately changes the output of the program as well, because all of the text literals in programs can be multilingual as well. And so that's an example of trying to embrace all of the languages in the world. So how do we support all of these multilinguals? How do we design data structures and algorithms? How do we make youth empowered to make their own educational programming languages that bring in their cultural ideas into the semantics of a programming language? Okay, Obtainable is our second to last. Learners must be able to access an educational PL and its tools and resources independent of their financial means. They have to be free, must not require paid access, must not require purchasing a device, and probably be viable on old hardware. This is fundamentally about economic justice. To be able to participate in the world, youth should be able to do that without being subject to the inequalities baked into our economic systems. Computer science has mostly ignored this, designing for those that can access modern devices and the internet. We often have them ourselves, and so that's what we're building for and testing with. And we leave everybody else behind as a result, sometimes in pursuit of profit, sometimes just in pursuit of progress. So platforms like Octo Studio, as fun and creative as they can be, it's free and only requires internet access to download, but you have to have a smartphone for this. And I gotta say that a lot of the families that I know in South Puget Sound near Seattle, it is a one computer household and the computer is a smartphone and they're on a 200 megabyte data plan. This does not work for that. TI graphing calculators are an interesting contrast to that. Cheap, ubiquitous, they're battery powered, they're programmable, you don't need an internet connection at all, you can do tons of things on them as long as you're excited about like monochrome pixel-based 2D media. There's problems with how TI has monopolized the marketplace for it, but it's an interesting contrast to some of the web-based media that we do. For wordplay, we've done something slightly different, which is free on the web, no active internet connection required, but because it focuses on text, the footprint is really small. It's just text and emojis, and so minimal device resources are really necessary for most of it. And it's fully functional on smartphones and tablets and really ancient school and library computers. Oh, I didn't get to show you the raining cats. There they are. Okay. So how do we finance something like this? What is the ecosystem of hardware and software that doesn't exploit youth and schools for profit, but really just enables them to learn in a ubiquitously obtainable way? And so those are, how can we reconcile a need for many different platforms that do this too, meeting a diversity of different desires and interests and needs? So there's a lot of challenging questions here about the economics of sustaining some of these. Democratic, centering power at the margins. PL must be governed by and accountable to learners and their communities of support, especially those marginalized in computing and society more broadly. And that means things like they should be open source. Designers must give it power to design to teachers and students instead. They must have community processes to engage and gain power and influence the design direction of these projects. And they should center community needs, not other goals like research or profit or innovation. Those are not the things that communities necessarily need. This is all about trying to make programmable media something that everyone has. And that means that programming language creators, like myself, we don't have any right to control the language unilaterally without the voices of those who are impacted by them. And so there are good and bad examples of this. Code.org is pretty ubiquitous in K-12 computer science education. They have an open source project, kind of, with contributor guidelines and advisory boards to shape product priorities. These are good things, but designer authority really is centralized. There's really one person at code.org that gets to decide what these platforms are and do. And that's not really a decentralization of power. The Processing Foundation does a great job of this. Lots of community contributions, lots of pull requests. It runs public events that solicit advocacy. It's a community that really tries to push out power to the edges, to where all of the community members, like teachers and creators, are doing their work. In Wordplay, we do a lot of different layers of shared governance. And so we have undergraduate communities of contributors. We have 6th and 7th grade classrooms that use Wordplay, and they very actively tell us what the platform should do. And we work with them to build student advisory councils that try to negotiate what features we might work on next. They set our product roadmap for all of it. And then teachers are the backup for them to help interpret what their knowledge is. And so it's been a really interesting exercise in trying to figure out, how do you give up power to 12-year-olds to design a programming language? And how do you make that a productive enterprise? And I don't think I have the answer yet, but we're trying a lot of things. So how do we sustain all of those communities? How do we pay for people's time to participate in them? There's a lot of open challenges there. I'll end with one last requirement. This one is pretty basic. Educational PL have to be sustainable for as long as a community needs them to be, respecting a community's capacity for change and a planet's capacity for computation. That means sustainable, maintainable, and resilient, but also discardable when they're no longer needed or they're getting in the way of other kinds of justice too. This is really about infrastructure, right? Making sure that PL exists for as long as they're needed. That is key to teaching. When a teacher invests in some curriculum, they're making multi-year investments in their course preparation and thinking about their learners' needs and all of the challenges that they might face on that platform. And so when platforms like Swift Playgrounds by Apple come out, they can get really excited about building practices around it. But when Apple makes no promises about how long it will be supported, and where every single year at an Apple keynote, they could just quietly abandon it and leave all of the teachers behind in the process, this is not enduring, right? That's not a practice that really helps teachers. I think Scratch is a good example of maybe a long-term sustainable thing, a large base of funding, a foundation, 2 decades of support, multiple re-implementations that show a willingness to invest and sustain the platform, with the caveat of the lack of democratic openness around shaping the platform. Wordplay, we're trying to do a lot of these things too. It's fully open source, it's web standards compliant, we have really minimal cloud dependencies that can be swapped in and out pretty easily. But it has a single point of failure at the moment, which is me. So if anybody wants to join for a PhD and help me broaden the maintainer base to really minimize that, that would be super helpful. So what are the models for trying to do some of this endurance over time? I think that's a big question, especially not only technically, but socially and politically to promote resilience. What would it look like, for example, for governments across the world to really build sustainable funding for this infrastructure for the world? We build languages and they're used globally, right? Why is the globe not paying for them? And I think anybody that maintains these now, some of those in the room who help support and maintain them, I think you know that the funding is really precarious. It's not something that's sustainable or predictable. So that's a big challenge. So what is next from this? I'm going to leave you with a few takeaway points and then we'll chat for a bit. Educational PL really play this instrumental role in structuring what kinds of computing education are possible and who education serves and what kinds of digital worlds we're making. And so being justice-centered means redistributing power to design those programming languages to learners and their communities, and intentionally centering and supporting their needs and their values, their cultures, and their abilities. So these requirements, these Altcode requirements, they're just one way to operationalize that, one possible way to focus our attention. Doing it is very hard. The challenges are technical, social, political, Transparency requires a performance hit. Multiculturalism requires political judgments about language, ideas, and culture. Democracy requires power sharing and conflict resolution and compromise. Accessibility can create complexity and often trades off with other kinds of needs that we might have. And endurance requires money and time, right? All of those things are hard to come by and hard to do. And all of this is in a world that increasingly bans and litigates and defunds diversity, equity, and justice efforts, doubling down on the very racial and patriarchal capitalism that created these problems in the first place. So we need a lot of things beyond that too, right? It's not just about PL. Properly funded public schools, diverse, well-supported CS teaching workforce, accessible classrooms, universal access to devices and the internet, and so on. So some of us are going to build some of this stuff. Some of us will organize around it, build communities to make it happen. Some of us will teach with some of these things and help shape what they are. I hope some of you will join us, creating a computational world that works for everyone, one programming language at a time. Thanks for listening.
Outstanding. Thank you so much, Amy. We have time for questions. About 5 or 10 minutes for questions. I see one in the back. Yeah, go ahead.
This is really amazing. Thanks so much. I have a question that I'm sure you get all the time, which is, what do you think of vibe coding? How does accessibility and, all of these principles play in, and what do we need to do to make vibe coding get to the level that we need it to be at?
Yeah, vibe coding, for those who don't know what it is, right? This is basically the worst kind of programming strategy that novices use, where you just keep on doing trial and error until something works. That's kind of the general premise of it. And another key premise of it that I think is really counter to some of these goals is transparency and agency, right? The premise of vibe coding is that you don't know what's going on. You can't understand what the machine is doing. You don't have any power to change its behavior other than through prompting, which is not any sort of deterministic process. And so if you view it from the point of empowering people to create software that meets their needs, if it meets their needs, it is empowering in that way. When it doesn't, and they have no facility to really adapt it to meet their needs, then it's very disempowering. We've all seen the stories of people getting something working and then everybody doing a whole bunch of denial of service attacks on whatever poorly implemented web service they constructed through vibe coding, and then they have to tear it all down. Is that a good outcome from this? I don't know. So, I don't know. I don't think it's compatible with most of these things, but it is one minimal form of empowerment.
Other questions? Lots of hands. At least 5 hands, I saw.
Wait, hi. Thank you for sharing all of this. I think it was really impactful to learn about all of your work at the moment. And I just had a thought listening to your talk of seeing how this effort is trying to, quote from you, redistribute the power. And I was wondering, what's your opinion on thinking about how we consider or how can we deal with the reluctance of people who are currently in power and who currently have the privilege, but their reluctance of letting go of this power when you're trying to redistribute the privilege?
Yeah, this is the classic activist dilemma, right? Do you do change from within or change from outside? And change from within means you try to convince that person to give up power, try to get them to see the light, try to change the power structures so that you can reconfigure it and make it work better. Change from the outside is very much about go make your own thing, go make your own communities, try to make something that's superior in all the ways you might imagine, and maybe in the process of that, gain power. And then you have to, once you receive it, figure out how to use it in a just way, too, which is the same problem that everyone has. So I don't know that there's a better way, and in some cases we have to do both. That's really what really powerful coalitions of people do. So let's make Scratch better, let's make wordplay better, let's make all of them better, and you just get to figure out which one you want to contribute to.
Pass it to me. A lot of hands very much.
Thank you so much for the really interesting talk. I'm finishing up my PhD and I'm facing a lot of these different questions about I've been developing and designing tech for a while, what am I going to do with it? And the issue that I've been facing is basically this transitory period between essentially I am the sole point of failure for this project,
Yeah.
and oh God, this needs to exist in the world and somehow be maintained and also needs money. And I guess I'd just be curious to hear your thoughts on those tensions of transitioning, of essentially like going from that point where you're no longer the source of failure, or like, and then how exactly different organizations take shape in your mind, I guess, if that makes sense. Because it's very easy at that point, you could be like, I'm going to do a nonprofit. I'm going to do a for-corporate thing. I'm going to do a co-op.
Yeah.
And so on.
Well, I don't have time to give a whole semester-long class on that topic, and I'm not the person to do it either, but I'll give the very short version of it, which I think is that when we build sustainable organizations for anything, we really have to think really carefully about where the money comes from and who makes decisions about it. And that's the part that is often not in our training. We don't learn about how to make those choices. But I think about things like wordplay, for example. Let's imagine there's a bunch of schools that take it up around Puget Sound and Seattle, and I keep it really regional and local. Maybe I go to the local superintendent and I say, do you have enough money to pay for some hourlies for my undergrads to do some maintenance on some of this stuff? That might be a small version of it too that's really close and local and central. The really big version of it is something like, we have created Java and the whole world will use it, and therefore the whole world shall pay for it, and we're going to make a multinational coalition that does public funding to maintain Java instead of having Oracle pay for it, right? But we haven't tried some of those models for sustaining programming languages. Most of the closest that we've gotten to that has been, let's ask NSF every 3 years for money to do something slightly different from what we've been currently doing so that we can keep paying to maintain this critical infrastructure. That's not sustainable. That doesn't make any sense either. So those are the questions to ask. I don't know if I have any answers for it.
Pass it to a head, a couple of hands right in front of you.
Thank you for your talk. Yeah, I want to ask a question about the transparency. Do you think the transparency is let the user to feel that they can control the system, or you actually show like the logic of the system to the user?
I'll just tell a brief story. One of the 7th grade classrooms that's playing out right now with one of our partner teachers. Most youth's experience with learning a programming language is that they do something, they don't know why it works, they don't actually understand what's going on, they do vibe coding, the equivalent of it, just by trial and error, until they get some output that they want. And they leave that experience feeling like, I succeeded once in making something that was kind of what I wanted, but I don't feel like I could make what I wanted, and I don't feel like I could do it again. That's not empowerment, right? When we do stuff with wordplay and they use some of the debugging facilities that I have, it's almost like they take it for granted as what should be, right? Something happens, they back up a few steps, and they're like, oh, and then they move forward. It's not that they're saying, oh, wow, look at this cool reverse debugger or timeline debugging thing. They're not thinking about it in any of those terms. They're saying, of course I should be able to see everything going on, and of course I should be able to comprehend at my will, whenever I want, what just happened. And then of course I should be able to rewind and then ask the teacher a question and get some support to understand that. So there's a very kind of organic self-efficacy that grows from being able to freely explore what's happening. But because most of our tools don't allow for that, and that agency isn't there, it almost always converges towards low self-efficacy, a feeling of disempowerment. And I think that's the dynamic that we're trying to shift through that requirement.
Thanks. So getting to that discussion of letting 7th graders design your programming language, there's a lot of ways that you could do this, and I'm kind of curious how you think about the times in which they ask for things either out of just, being young, not, being aware yet of all the trade-offs that might be in conflict with some of the, principles of Altcode or of justice. How do you, one, do you have any stories of, things big or small in that pace, but how do you have that discussion with, 7th grade? It's like, that is a cool idea, but that actually conflicts with this other idea that might be more important, and yet the 7th grader might also be like, I don't really care about that other idea, because to me, the game that I want to build, what do those conversations go like?
Yeah, and that's what conflict is about, right? So an example is we had to decide whether to use the keywords true and false in this language. And that debate amongst youth was a really complicated one because all of the English fluent kids were like, yeah, true and false, that sounds great. All of the kids who spoke other languages, they said, my language doesn't have false. And the word shouldn't be lie because that's the closest thing that we have in our language. And so then there was this conflict we had to resolve. And it was one that we facilitated where there was some debate about what that would be. And the compromise that they all led with, which I don't think made any of them perfectly happy, but was something that reconciled the conflict, was we don't use any words. We just use symbols that nobody knows the meaning of, and then everybody starts on the same level playing field, where they have to figure out what they mean, and then at least everyone's starting from the same position, and there's nobody being advantaged by anything. And so it was almost like they were happy to settle for something that was universally mediocre instead of optimized for one culture. And that was the value system that they used to make that decision. But there's a lot of stories like that I can tell.
Absolutely delightful, Amy. Beautiful. And also thank you for calling out the kind of literal attack on the academy by the current administration. I think we're all kind of, it's not an, if but when kind of thing going to happen across the board. I actually was reflecting on this kind of beautiful word, structuring of how we can think about languages. And I was obviously in a very selfish mode, also thinking about the things I do in sort of design, innovation, prototyping, physical kinds of designs. And I felt like they certainly are aspirations we would love to have too. It felt like almost any creative practice, largely engaging with technology, I think, because maybe it could apply to painting and sculpture and lots of things. But I was drawn to this actually applies much more broadly. I know that you're in this world, but I would love to see it much more broadly spoken about. And it got me thinking, this is another one of those elephants in the room. It's kind of the default question, but it's very important. We now have a new player on the field, like, AI and machine learning is now a thing that we are it's grown up, so to speak, and we're starting to grapple with and bring it into it's another creative tool in our sort of practice. How is that going to change the calculus of how this can be elevated or, be more broadly democratic and participatory?
Yeah, I mean, just to follow from the starting point of your question, what are these for Gen AI? And I think that if you take some of these literally for what they are and the way that I describe them, you can see that we're not doing most of these for Gen AI either, right? Like, it's certainly not democratic, certainly not transparent. There's all kinds of ways in which they're not really reckoning with the total multicultural world that we live in. So there's all of these failures on that front too. And so at one level, we should be having similar conversations in that world, independent of the PL conversations. And I think that many people are, maybe just not in the same kind of structure, right? But I think the general practice of naming some of these values that we think are really linked to our collective liberation is probably, maybe it's a way to organize things. And I think what I'm trying to do here is really organize. How do we bring everybody together around some shared direction and then move in that direction and pivot as necessary? In terms of the particular challenge of trying to do this for any particular media, programming languages or Gen AI or any of those other things too, these are going to mean different things, I think, in each of those settings. And I think that's part of the work that we've tried to do here is what do they mean for the medium of programming languages in particular, and how is that different if you jump over to, let's just say, classic 1990s user interface design? They probably mean different things there too. And I think that's meaningful work for us to do for all of these different media, is to have the conversations about how do we operationalize them.
Yeah, thanks.
Thanks, Amy.
Yeah.
I have a semi-thought-out question, which is, as computer scientists, right, we think about engineering ways to address these values and these questions. And I'd just like to reflect your reflections on when is the right impulse to build technology and when is the right impulse to actually not introduce new technology, but build community around what already exists. So I'm particularly thinking about one of the successes in broadening participation in computing over the last 2 decades have been the Arduino and processing ecosystems, right? And from a kind of CS research perspective, you're like, oh, you're still writing code in C or in Java or in JavaScript, right? There weren't particularly new research ideas that were driving the agenda, but the agenda was driven by building community and making it accessible, maybe not to everyone, but to 1 or 2 layers beyond traditional CS audiences. And it was all done through community. You still had to deal with pointers and memory management and all the weird stuff, but there were people on the forum who wouldn't yell at you for asking questions and who were helpful.
Yeah. I have this PhD student, Jane Everson, and she's wonderfully engaged in all of the physical, tangible media and are doing Arduino, things like that too. And it's been a long journey for her to recognize that the particular motivations that she has to overcome the warts of C and C++ to engage in that media, that those aren't shared amongst the youth that she teaches. Some of the youth are like, fine, I'll learn this weird thing and then I'll overcome it and it'll be great because I get to make this thing that I want. Others get completely tripped up on it too. And so there are ways that I think PL like that we embed into and that we inherit from the past. They do create structural gatekeeping in a certain way. We don't quite understand yet, I think, the precise ways in which the choice of a particular language ends up determining who does and doesn't engage it. But it is happening, and she's quite confident that it happens. And she was doing teaching for 10 years and noticed all of the ways in which certain kids would like the aesthetics of C and hate the aesthetics of C and opt in and opt out accordingly. So I don't know. I think maybe it's a different world that we're needing to build here, which is an idea that things are so easy to pick up and learn and understand and so transparent that it kind of doesn't matter what we choose because there's so many different options. People can find the thing that works for them. And I can't imagine that it's going to be any one thing, right? Like this vision should result necessarily in 50 different platforms and media that are all really easy to pick up, multicultural in all the ways we imagined, democratically organized. That to me would be a healthy ecosystem, as opposed to just inheriting the past and trying to make the best of it.
Maybe one last question.
Yeah, I want to say this talk was very exciting. And I wanted to ask, how do you juggle wearing all the hats to build? So like, for example, when I sit down and read my Freire or my Vygotsky, I can kind of ideate on how I would want to bring those ideas into the classroom and kind of make parallels to engineering education. But then when I sit down in front of VS Code, it's very hard for me to bring my Freire and my Vygotsky in. And yeah, how do you wear all the hats at the same time?
Yeah, that's a really great question. I do a lot of pre-service teacher education in our College of Education, so I work a lot with teachers who are wrestling with the same question about how can I be a teacher and think about the engineering parts of computer science and also think critically about the education systems they're in and the programming languages that they're using and the assignments that they might be designing. There's just so many different perspectives to take on the same work. And so we actually don't encourage them at all to try to wear all the hats at the same time. We encourage them to be very explicit about which hat they're wearing and remember that for any given hat that they're wearing, they eventually need to take it off and put on the other hat too. And so it's almost like you have to build this split designerly personality to give some space to the engineering, to give some space to the sociopolitical, to give some space to the pedagogical, to give the space to the relational, which teaching always is. And the skill to get good at is moving between those and feeling comfortable moving between them fluidly. And that's the thing that I think the teachers that we prepare are really trying to master in the end. Because none of them is the right perspective. All of them are necessary. And we can only move forward if we do all of them well.
With that, let's thank our speaker again. Thank you so much, Amy. Outstanding. Outstanding. We still have a couple minutes if you want to come up and talk to Amy. We're going to